Hello everyone, welcome back to my channel. Today I'm going to show you how to make a Bluetooth remote control smart car that you can control from your phone. So without any delay, let's get started. I'll list all the parts I'm using down in the description. I'll be using a robot chassis kit that has all the parts necessary for the car's body. The chassis kit contains 4 gear motors, 4 wheels, bolts, nuts, spacers and encoders, 2 laser cut acrylic pieces and some wire. Now let's move on to our electronics. Arduino Nano, L298N motor driver, HC06 Bluetooth module, perforated board, male and female header pins, 2 terminal blocks, 24 gauge solid core wire, PCB Mount Slide switch, brass hex spaces, 2 3.7 volts lithium ion batteries, a lithium ion battery holder, and female jumper wires. First, drill 3mm holes for the PCB spaces to mount the motor driver and the Arduino circuit. I recommend drilling the holes before removing the protective layer. Mark out the holes carefully and make sure they align with the boards. Once you drill out the holes carefully, remove the protective layer on top of the acrylic. Be sure to get all the little pieces so that it's completely clean. Next, grab some hex spacers and some screws. Fix them into position as shown here. Make sure they're not tilted and perfectly vertical. Use a screwdriver to tighten them further. Do the same for all the holes. Now that they're all fixed into position, we can now fix our battery holder by making use of these 2 holes shown here. Now, we grab 2 bolts and fix the battery holder into position like this. Next, open up the plastic bag and grab the brass spacers and the short screws. Fix them onto the top layer like this. Do the same for the holes in the position of the brass spacers shown on the screen. Next, to fix the motors, grab one of these plastic support pieces and put the long screws through the holes. And get one of the other plastic pieces and line them up in the same position like this. Once the screws are completely through the other end of the plastic support piece, tighten them with the bolts. Now this is the part that I realized I made a mistake. In the position that I drilled the holes for the PCB, the screws on the bottom side were preventing the gear motors to be fixed into position correctly. So therefore I had to realign the PCB, mark out new holes and drill through them. Then I fixed the hex spaces into position again, and they're lined up perfectly. Now I fixed all 4 motors into position without any trouble. Next, grab the wire in the kit and some short wire to solder the connections for the motor. Solder the connections like this. They're soldered in this way to make sure that we can drive both motors from the single output pins on the motor driver. Now fix the bottom layer on by lining up the second acrylic layer with the holes on the brass hex spaces. Use the shortest screws to fix them into position. Next, pop in the wheels. They're pretty simple. Line them up with the gear motors and they'll work. Next, place the motor driver into position and use the nuts to fix them tightly into position. Next, cut the wires down to length and tin them. This is to make sure that they stay nice and neat. Next, put the wires into the terminal blocks, which are the output pins of the motor driver. Do the same to the wires on the other end. Make sure that they're fixed into position tightly. Now that the wires are fixed into position correctly on both ends, we can now move on to the schematic and build our Arduino. Okay, now let's look at the schematic of Arduino's Bluetooth controlled card. So we have a HC06 Bluetooth module here. Its VCC is connected to the 5V pin of the Arduino Nano. Its ground will be connected to Arduino's ground. Its transmit pin will be connected to the receive pin of the Arduino Nano. Its receive pin will be connected to the Arduino's transmit pin. We have our L298N motor driver here, and two DC motors are connected to its output pins. Make sure they're in the 3 to 6 volts range. If you're using gear motors which are bigger than this, it'll end up drawing too much current and it can even end up damaging your motor driver circuit. So strictly use the ones within 3 to 6 volts range. The four digital pins, digital pin 9 to 12, are connected to the input pins from input pin 1 to 4 on the motor driver circuit, and they'll be driving the motor's speed and direction in which they'll need to rotate. We have a 7.4 volts lithium ion battery pack here with a switch in between to control when we want to turn the circuit on and off, and its positive connection will go to the 12 volts pin on the motor driver, and it will also be going to the voltage in pin on our Arduino Nano, and the ground will go to the ground of the motor driver and also to the Arduino Nano. Now it's very important that both your Arduino Nano and your motor driver should share some sort of common ground with your power supply, or else both of them cannot drive signals between each of them. So be sure to keep that in mind when you're soldering up your circuit. Okay, now that the schematic is completely explained, I'm gonna solder up my circuit and show it to you. See you soon. Okay, I have my circuit soldered up. It's exactly as shown on the schematic. I have my Arduino Nano, the signal pins for the motor driver, the slide switch to turn the circuit on and off, two terminal blocks to power supply to the Arduino and to supply power to the motor driver. I have female PCB headers to mount my Bluetooth module into position. Don't solder the Arduino and the Bluetooth module directly to the perforated board. If you ever make a mistake, or if you want to remove them and use them for something else, it'll be very difficult. I soldered up the connections on both sides to make efficient use of the space. Okay, now let's mount the PCB onto the car. Now I mounted the circuit onto the car and I fixed it into position securely by using some nuts. I made connections between the Arduino circuit and the motor driver with some female jumper wires. I got the positive and negative wires from the battery holder and I connected them onto the circuit using the terminal block. I mounted the Bluetooth module in and I mounted the lithium ion batteries into position. I also used some shorter wires to give power supply connections to the motor driver circuit. As an additional feature, I added two white LEDs which have a 330 ohm resistor connected to their positive terminal to make sure the current doesn't cause them to overheat and blow up. This isn't necessary, but you can add it if you want to. I connected the two terminal wires of the LEDs into the power supply connections for the batteries. There we go, the circuit is switched on and it seems that everything is working fine. The power indicator on the motor driver is also turned on, and the LED lights are now glowing very bright. Okay, now let's move on to the coding section. Okay, now let's look at the coding part of the Arduino's Bluetooth remote control car. So first, I have a few macros defined here. They define the direction of the motor and the 4 signal pins that we need to give a high signal in order to make them turn on. Now, if you don't know which motor will rotate in which direction, you can just use the Arduino's 5-volt pin and touch it on each of the signal pins on the motor driver to see which direction the motors rotate. So we have a char variable here named direction, and this will simply just keep track of the characters that we receive from our Arduino's app. So depending on that, it'll cause the motors to rotate in that direction. Okay, now we have our direction functions, where we simply just do a digital write to each of the motor pins. For forward direction, we get both the left motor and the right motor to rotate in the forward direction, so we set both of those pins to high and we set the remaining ones to low. And for the backwards pins, it's the opposite. We set the backwards pins to be high and the forward pins to be low. And then for the right direction, we basically set the left motor forward to be low. We set the left motor backwards to be high, and then we set the right motor forward to be high, and we set the right motor backwards to be low. This way it'll cause them to rotate on the spot towards right, and for left it's counterintuitive. We do the exact opposite. Okay, and next for the stop function, we just set all the pins to be low, so none of them rotate when we call this function. Okay, in the void setup, we just start off our serial monitor at the baud rate of 9600. That's the rate at which we're going to receive data from our Bluetooth module, and we just set up our pin modes for all the motor pins, and we're declaring them to be outputs. So we'll only be writing signals to them, and we won't be expecting to receive any data from those pins. Okay, now in the void loop, we set up a if statement which has our conditional to be serial.available being greater than 0. What this means is, once we're receiving data from our Bluetooth module, we'll finally enter this if statement, and all the code in here will be executed then. So once we're actually sending data from our Bluetooth module, when we press our buttons, data will be received by the Arduino from the Bluetooth module. And once we enter that, our direction variable is going to be given given whatever is read from the serial monitor. So that's going to be our transmit and receive pins. And once our Bluetooth module sends data through those pins, Arduino is going to read them and store them into this variable. And then once we do that, our if statements simply just check if the direction variables meet each of these characters. So if we press the forwards button on our Arduino app, F will be sent to this direction variable from our serial.read, and our motors will spin forward, and we call the forwards function. If that is not the case, we check if we send a B, then we're basically pressing the back button, and the backwards function will be enabled, which will cause our Arduino car to move backwards. If that isn't the case either, then if we're sending an L, then we're pressing the left button, and our Arduino car will turn left. And if that isn't the case, and we're sending an R, we're pressing the right button, and we call the right function, which will cause the Arduino car to rotate towards right. If none of these are the case, and if no data is actually being sent, then our car will simply just stop, so it won't even move, and it'll just wait to receive a command. And our void loop function, and all of this code is in our void loop function, so this will constantly keep looping around and check if these conditions are being met. And an important thing to keep in mind is you want to change our board to be an Arduino Nano. We go into the area of board section and choose our Nano. If the ATmega 328P isn't working, then we can choose the old bootloader, and we just select the port that we want our Arduino is connected to. One important thing to keep in mind is you want to dismount the Bluetooth module before uploading the code onto your Arduino using this button here. And the reason for that is the receive and transmit pins on the Arduino Nano, or any of the Arduinos in fact, cannot be busy whilst transmitting data to them or uploading data to them. So keep that in mind. It's very important to remove your Bluetooth module whilst uploading the code, and connect it back once the code is uploaded. So that's that. So I've already uploaded the code onto my Arduino, so we'll move on to the other part and see how it'll do. Okay, now I connected the Arduino to my computer using a micro USB cable. Now to upload the code, I'm going to hit the upload button. Before we do that, as I mentioned before, I'm going to remove the Bluetooth module out of the position, because the transmit and receive pins must be free before uploading the code. Select your port correctly and set this correct area of board. Now upload the code. We can see that the sketch is compiling perfectly. And now the code is being uploaded to the Arduino Nano, as we saw. Once the code is uploaded properly, disconnect the USB cable and place the Bluetooth module back into its position. Next, we must install the app to control the car. Go to the Play Store and search Arduino Bluetooth Control RC Car. I already have the app installed and I'm going to open it. This is what the control panel looks like. At the start, the app will ask you to turn on your location. Please do that. If you don't do it, then it won't allow you to access your car. Click the gear icon and press connect to car. For new users, press scan for car. I already have my HC06 paired up. Once the green light on the top left hand is glowing, it means that it's connected up to your car. The controls are extremely simple, as seen on the screen. It moves forwards, backwards, and by making use of the right and left button, the car will spin in that direction. Okay, that's it for today. Let me know how the project was done in the comments. I'll list all the components and the parts that I used down in the description along with the source code. Don't forget to like, share and subscribe. Thank you very much, and I'll see you guys soon with another project.